Good evening, friends. Now I want to discuss about the valency bond theory. What is valency bond theory? Valence bond theory. In chemical bonding, now we discuss about valence bond theory. What is valence bond theory? Valence bond theory discuss about the covalent bond. It will discuss about the covalent bond. In chemical bonding, all theories like valence bond theory and valential electron pair repulsion theory, molecular orbital theory, these are all discuss about the covalent character, covalent bonds. It only discuss about the covalent bonds like valential electron pair theory or molecular theory or valence bond theory discuss only about the covalent bond. What is valence bond theory? What are the some of the important? It is overlapping of the atomic orbitals. Overlapping of the atomic orbitals, then only it will form the covalent character. First you have to remember this introduction about valence bond theory. Valence bond theory mainly discuss about the covalent bond, about the covalent nature or covalent bond. Remaining all theories are also discuss about the valence electron pair repulsion theory and molecular theory also discuss about the covalent bond. What is covalent bond is how it will form the overlapping of the atomic orbitals. We can consider how the overlapping of the atomic orbitals. Some of the important points we have to discuss. First point is, number one point is covalent bond formed by overlapping of atomic orbitals. First point. Second point is overlapping must be approached 50% only. Why? Because 50% must to be approached less than 50%. Less than 50%. Why? Because less than 50%. If one of the atomic orbital is two atomic orbitals, for example, this atomic orbital, this if it is s orbital, they are in center. By approaching close to each other, their nucleus having get repulsions. That's why up to 50% only maximum it is possible to overlapping of the atomic orbitals. After this, it will get unstable. Why? Because they will get the repulsions. Then that's why the overlapping must be approached less than 50% only. Now, the overlapping of the atomic orbitals with opposite spins. Overlapping of atomic orbitals with the opposite spin means if you take this positive side, this is having negative. These opposite signs only will overlap. Next, fourth one. A extent of overlapping depends upon the bond strength of, that is whatever the covalent bond. If it is more, overlapping strength is more, that is bond is strong bond, it will form strong bond means bond energy is more. Bond energy more means reciprocal of bond length. These are some of the important conditions. First is covalent bond is formed by overlapping of the atomic orbitals. Means atoms should come close. Atoms should come close. Overlapping must be approached to less than 50% only. Overlapping of atomic orbitals with opposite spin only, then only they will overlap. The extent of overlapping depends upon the strength of the bond. These are some 4 conditions remaining also there. This overlapping of the atomic orbitals having 2 types. One is axial overlapping. Overlapping is 2 types. One is axial overlapping. Second one is lateral or sideways overlapping. Lateral or axial overlapping, and also the head-on overlapping. Axial overlapping and also head-on. One more is parallel overlapping and also sideways overlapping. Sideways overlapping. These are the 2 types of overlapping. One is axial overlapping, another one is lateral overlapping. Sideways. Axial overlapping or head-on overlapping will form the sigma bond only. Sigma bond formation. In case of parallel overlapping or sideways overlapping, it will form the pi bond. How will it form the sigma bond? How will it form the pi bond? We will discuss. Next, this is comes under 4th point. Next, 5th point. Overlapping must be same sign. Means positive orbital overlapping. Why? Because in case of electron, we denote it with orbital. For example, this is one of the orbital, p orbital, px, py. This is the electron. If you denote it with the electron maximum possibility, electron is having wave function. The orbital, it is not fixed position to identify the electron. Electron is moment of the wave function, means it is having plus and minus charges. This is the orbital. In this, the maximum probability of movement of electron is denoted with orbital. In this orbital only it will evolve with the electron. In this case, we have to draw the graph like this. This is having wave function. This is having positive charge, minus positive, minus positive. These only they will form the overlapping must be in the same sign only. They will overlap. Now we have discussed valence bond theory. Valence bond theory means it discuss about the covalent bond, regarding about the covalent bond, how it will forms. If you want to form the covalent bond, the overlapping of the orbitals must be there. How the overlapping will be possible? In case of overlapping, the first point, in overlapping with the atomic orbitals, means the 2 atoms must be comes close. The overlapping must be not 50%, be less than the 50%. The overlappings are 2 types. One is axial overlapping, another one is parallel overlapping or sideways overlapping. If it is axial overlapping, it will form the sigma bond. In case of parallel overlapping, it will form the pi bond. Overlap must be in the same side, plus plus or minus minus only the argument. If it is, how it will overlapping, if it unpaired electron is opposite signs, then only they will form the overlapping. Atomic orbitals overlap will form. This is the some of the the depends on the strength of the overlapping. Extent of overlapping depends upon the strength of the bond. If it is more strong, in case of axial, it will form the more. In case of sidewise, it will, the extent of overlapping will be very less. Take for example, in case of axial overlapping, take axial overlapping. In case of axial overlapping, for example, if you take s orbital, one more s orbital, it will form, this is the SS, this means this is sigma 1, in which this is non-directional, because this is having not any direction. If it is approached any way, they will same. That's why this will form the SS orbital. S orbital is spherical shape, spherical is symmetrical. That's why S will form, it will SS sigma bond. This is one of. In case of S orbital, any p orbital, positive charge will form, this is p orbital, this is s orbital, will form the sp sigma 1. This is one of the example. If in case this is the axial overlapping, if in case any p orbital plus p orbital, positive also will form p orbital, p must be s and px, or any you can take y or whatever it may be. In case of p either xx, if you take in combination of yy, you take pyy. In case of combination of pz, zz. Like this only they will form the sigma 1. This is also sigma 1. In case of axial overlapping, means along the axis, it will form the three types of bonds. One is this one, second one this, third one this. How it will forms? These three conditions only. In case of, if you take in this case px plus py orbital, it will not form the sigma bond. Why? Because the x-axis is like that, but this is like this, plus minus, this will not form the bond. Only xx, yy, zz only will form the sigma bond along the axis. That is axial overlapping or head-on overlapping, and also called head-on overlapping. SS orbital, SP orbital, PP orbital, PX or PX. In this case, we can take it. Only will form the sigma bond. This overlapping is called axial overlapping or head-on overlapping. These three types we have to remember. In this case, hydrogen molecule. In this case, hydrogen and hydrogen sigma bond, it will exist. For example, if you take S and P orbital, if you take any HF, HCl, HBr, these molecule will form the S and P orbital. If you take S, you can, by using hybridization or by using electron configuration, we can define easily hydrogen and fluorine. Hydrogen having one S orbital, fluorine having P orbital, they will form. If you take, in this case, if you take any boron trifluoride, for example, in this case boron having p orbital, fluorine also having p orbital, pp sigma bond will form, and also other bonds will form, but pp overlapping will possible in the case of boron trifluoride. With clear explanation later we can discuss. Now I have to understand easily how axial overlapping possible head-on overlapping, in which cases which molecule will show the axial overlapping or head-on overlapping. These three orbitals only will form the sigma bonds. Next, we have to discuss about the parallel overlapping or lateral overlapping. For example, we have to, one of the example important to HF, HCl and HBr, which is having close to the nucleus, if you take identify bond length or bonds, first we have to bond length we have to discuss, which is having more bond length. How can we solve this? So bond length is more in which case? If close to the nucleus, that is forms strong bond or tightly attached to the nucleus. Means if it is if bond is close to the nucleus, means it will form strong bond. In this case s orbital and this is 2p orbital, this is 1s and 3p, 1s and 4p, which is close to this 1s 2p orbital is close to, that's why this will form the strong bond. Strong bond means having less bond length, this is having more bond length. Like this you can solve any problem. Next, one more that is different affinities. Parallel overlapping or sideways overlapping. In this case, having different types. For example, if you take one of the p orbital plus p orbital, you take px or py, whatever it will be, px, pxy, they will combine p orbital and p orbital, will form pp pi bond. This is one of the type. In this case, if you take one more p pi and also d pi form, if you take this one, if you take d orbital, this is d orbital, plus minus plus minus plus minus minus plus, combine will form this will be the overlapping. This is p pi d pi. If you take one more, third one, d pi d pi, plus minus, then come this is d pi bond. These are the three types of bonds exist in this case: parallel overlapping or sideways overlapping. One is p pi, next p pi d pi, d pi d pi. These are the some of the examples of the, in case of parallel overlapping, sideways overlapping, or in case of axial overlapping or head-on overlapping. These are the three overlappings. If you can identify any different molecules, if in this case we take oxygen molecule, O2, O double bond O, one is sigma bond, one is pi bond. This is p pi, pp sigma, pp pi. This is exist. In case of if you take sulfur trioxide and also H3PO3, in this case H3PO4, you can identify easily p pi d pi and d pi bonds. These are some of the examples of the sideways overlapping and parallel overlapping. In which molecule will show this bonding, have to remember easily. Next, The difference between sigma and pi bond. Sigma bond difference between sigma and pi bond. How to remember easily. What is the definition of a sigma bond? Axial overlapping or head-on overlapping will form the sigma bond. In case of pi bond, parallel overlapping or lateral overlapping, in which cases possible? Sigma bond SS, SP, PP. In case PP, PD, DD molecule will form. The types of others. Third point is the extent of overlapping. Extent of overlapping more means the axial, like this. In case of these two, like this, overlapping is stronger compared to like this sideways overlapping. Sideways overlapping breaks easily, but axial is more stronger. That's why this extent of overlapping more means it will form more stronger bond. Bond is more stronger means bond energy is more. Bond energy more means bond length is less. Like this we have to. The extent of overlapping is very less. Extent of overlapping very poor, less. Next, third difference is this is approximately 86 kilocalories energy will release. In this case, 65 kilocalories, very less. That's why this one. This is the energy to break the molecule. Sigma bond. Fifth point is sigma bond exists alone. Sigma bond exists alone. And it will exist in single only. In case of HF, HCl, like this. But pi bond does not exist alone. It will always combine. Pi bond does not exist alone. It will always exist with pi bond, sigma bond. In case of nitrogen, you see 1 sigma 2 pi. In case of oxygen, O double bond O. 1 sigma 2 pi bonds. In case of 1 sigma 1 pi. Like this, it will exist along with sigma bond only. Does not exist alone. Sigma bond exists alone also. These are some of the important differences between the sigma bond and pi bond. Go one more last important topic. Rotation of sigma bond is possible. Sigma bond rotate easily because in this case of axial, in this case, if you take in this case from sigma bond, it will rotate easily. But in case of pi bond, it will not rotate easily, it will break. That's why it will form restricted rotation. Possible only restricted rotation only. Why? Because in case of pi bond means you cannot rotate easily because the axially it will rotate, it will breaks. That's why it will form only possible restricted rotation. But in case of sigma bond, rotation is easily possible along the axis. But in this case, it is not possible. It will breaks. Only restricted rotation is possible. These are the some of the differences between the sigma bond and pi bond. Remember axial overlapping or head-on overlapping. SS, SP, SP, PP bond will orbitals will form the sigma bond. Next, extent of overlapping is more stronger bond. 86 sigma bond exists alone, HF and HCl. Rotation of sigma bond is possible. In case of pi bond, parallel overlapping, lateral overlapping, PP, PD, PD, DD. Only we will form the 5 bonds. D pi, D pi, D pi like that. Extent of overlapping is very poor because there is a sideways overlapping. Pi bond does not exist alone, it will exist always combined with the sigma bond only. There is free rotation is not possible, only with the restricted rotation only possible in case of pi bond. This is about the valence bond theory, how the bonds will form existed like this. Thank you.